Hi everyone, we're going to do Leetcode 242 today, valid anagram, and in this problem we're given two strings S and T and we need to return true if it is an anagram of S and false otherwise. So for example, we have two inputs here, we have anagram and negagram, and the output is true. So basically an anagram is two words and they both have the same letters and they use it only exactly once. So for example, in the second one, we have S equals rat and T equals car. It is false. So because the second input has the letter C and in S, there's no C there. So now that we know that what an anagram is, let's see how we can solve this problem. So basically how the straightforward approach would be is we're going to just run through the first input and just count the frequencies of each letter. And the second input, we run through the second input and then we are going to just subtract the frequencies from the first input. And once we get the resultant frequency numbers, we can just run through them, each letter, and see that if it is equals to 0, if all of it equals to 0, then we know that these are two valid anagrams. So let's just, let me show you how it looks in a code. So we're going to say for letter of S. That's the first one. What we're going to do is we're going to create a frequency object. We're going to create frequency object, or you can use a hash map as well, that will work. So in this case, we're using the object, we're going to say frequency letter, and then we're just going to look at it if it exists, and we're just going to take the number or not. We're just going to put 0 and then we're going to add 1. So this will actually count all the frequencies of the letters in S. So we're going to do the same thing in T. So for letter of S, for letter of T, we're going to say frequency letter equals, or we're going to say, we're going to have to do an if statement. Say if frequency letter, then we're going to say frequency letter equals this minus 1. So it's getting a bit long, so I'm just going to create a block here. Okay, so now that we have added the frequencies, then we look into the second input and we have removed the frequencies. We need to check the frequencies now. So let letter in frequency. What we're going to do is we're going to say if frequency letter does not equal 0, we're going to just return false. And then if we go through all the frequencies and every one of them is 0, we're going to just return. And then let's just run this test case and see if it passes. Then let's submit it. Okay, we got a wrong answer here. Let's just use this test case, and as you can see here, both inputs, they have different lengths. So what I'm going to do is we're going to just look at the lengths and just say if s length does not equal the second input t dot length, then we are going to just return false. So that's sort of like a base case. So if the lengths are not equal, then we're just going to say it's false, it's not an anagram. Let's just run that. And then we have passed test case. Let's just submit it, see if it's accepted. And as you can see, it's an accepted solution. So this is the straightforward approach. As you can see here, since we're looking at the lengths of both and see if it's unequal, then we just return false. we can now know that whenever it goes through into this code block here, after that, we know that s dot length equals t dot length if it goes through here. So basically for every loop, this especially these two loops is O of n, and then this third loop will loop through the frequency, which will be less than n, but that's just for simplicity, we're just going to say it's O of n again. So the runtime is actually O of n, O of 3n approximately, and the space complexity will be I guess O of n, because if you have a growing word, this frequency object will also increase. So space complexity is O of n as well. Okay, so this is one approach we can actually do for this problem. We also have another approach, and I'm just going to show you that now. So here we have like maybe three loops. Maybe we can do it in one, the first two in one. So instead of creating an object, what we're going to do is I want to use an array instead. So I'm going to create a new array, and I'm going to say I want this array to be 26 in size. So the reason why I want to do this is I want to create a data structure that represents the alphabet. So if you know, the alphabet has 26 letters. So I want to initialize everything as 0. So at the start, we have all the letters as a frequency of a 0. So what we're going to do is I'm just going to create a loop with a number index. Okay, let I equal 0. I is less than s dot length. And then we're going to just increment I. So what we're going to do, instead of increasing by 1, so we're going to look at frequency, and we need to find the index of that particular letter in the alphabet. So to do that, I'm just going to create a variable called position. I'm going to call it position s, and what I'm going to do is I'm going to go s.char code at I, and then I'm going to minus the string a, char code at. So this will give me the position of the alphabet. So basically this is just we're finding the ASCII code of that letter in S, and we're finding the ASCII code of A, and if we subtract it, we will get the actual position from 0 to 25. So what we're going to do is we're going to say frequency pos S, and then we're going to say okay equals, or we're just going to just increase that. I think this will work. Not sure. Let's just be safe and just do an equal, and we're gonna just take that and plus 1. So we're gonna do the same thing for t. So we're gonna find the position of t, and instead of adding this, we're going to minus it. So we're gonna minus, so this will be t plus t. So basically we're doing the same thing as these two loops, so we're going to remove that, but instead of an object we're using an array, and then we're going to have to look at for letter of frequency. We're going to say okay, if letter does not equal 0, we're going to return false. Just put this in one line, and we can just return true. So let's just run this again, see if it works. And it does. Let's submit it. So this one is a simpler solution. It might actually be still O of n, since we're using a loop here and we're looping through the input. but it might be a little bit faster because we're just using only one loop. So this one is a sort of quicker solution. And also in terms of the space complexity, this is actually, you can actually call it O of 1, because this will always be consistent. It's always going to be 26. You might argue that the first solution will only grow depending on the number of unique characters. So unique characters, so that could also be limited. So the first solution where we're using the object could be limited to just 26 letters as well, but it grows at O of n. So those are the two trade-offs. You can look at the two solutions and see what works best. But we've come to the end of this video, and I hope you enjoyed it. If you did, please hit the like button and subscribe to the channel. And if you have any questions about this problem, just drop a comment down below. We're going to do more lead codes in the future, and stay tuned for that, and I will see you in the next video.